Wow, we've talked about a lot of different technologies in this course so far. It's enough to make your head spin. So let's start by reviewing what all these technologies are that we've talked about and how they fit together. And once that's fresh in our minds, let's talk about how to assemble them into larger systems that can solve real-world business problems and how you might actually use these technologies in the real world, which is, at the end of the day, all that really matters, right? Let's take a look. All right, let's review some of the different technologies we've covered in this course, and there have been a lot of them, so I think it's worth going back and reminding ourselves how they all relate to each other and how they fit together before we start to talk about how to assemble these pieces into systems that can solve real-world problems. So to review, we started off talking about the core Hadoop ecosystem, and there's really only a few components in pink here that make up Hadoop itself. Everything else is sort of ancillary add-on technologies, so to be fair, if we're just talking about Hadoop itself, it's really only these three things. HDFS, the Hadoop Distributed File System, which is responsible for managing the storage of your data across your entire cluster. So it breaks big data into little blocks that are replicated across your cluster and distributed throughout your cluster. Yarn, yet another resource negotiator, sits on top of HDFS. And like HDFS is managing the storage of your data, Yarn is managing the computation and the processing of your data. So it's responsible for figuring out which computers, which CPUs, which processes to actually use to process your data and using whatever framework you're using on top of it. So it figures out what gets run where, whereas HDFS figures out what gets stored where. And sitting on top of Yarn is MapReduce, which is another core piece of Hadoop itself. MapReduce is a technology that allows you to transform and aggregate data across your cluster using Yarn to figure out how to distribute that work. So with mappers, you can transform your data, and with reducers, you can aggregate your data. And then sitting on top of MapReduce, it's like a big old layer cake. We have Hive, which offers a SQL-like language on top of your data, Hive query language to be precise, which allows you to issue SQL-like queries to analyze the data that's stored in HDFS and use MapReduce and Yarn to actually distribute the processing of those queries. Similarly, Pig sits at the same level, and that provides a scripting interface very high level using its own language called Pig Latin. Let's zoom out a bit and get our bearings again. We also talked about Tez. Tez is basically an alternative to MapReduce that's based on something called a directed acyclic graph. And that can be much more efficient than MapReduce in actually figuring out how to distribute the processing of, say, a SQL query. And that's why things like Hive and Pig have alternate interfaces for Tez. They can use Tez instead of MapReduce and get very substantial speed gains as a result. We also talked a lot about Spark, one of my personal favorite technologies here. And like Tez, it's also based on directed acyclic graphs and in-memory processing, so it's really, really fast. But it's not just an API. It's not like a little middle layer that things like Hive and Pig talk to. Spark is a beast of itself. So you develop Spark scripts using Scala or Python or Java, and there's an entire ecosystem available to you there with Spark Streaming, Spark's machine learning library, and GraphX, which is made for graph processing, and more. So Spark is a very powerful and very popular toolkit for actually writing code, writing programs that analyze your data across your cluster. And we talked about Apache HBase. HBase sits alongside your Hadoop technologies and offers a NoSQL, non-relational database based on Google's Bigtable picture. And as you might recall, it is architected to favor consistency above all else. And there are other data storage technologies we looked at as well that aren't quite as tightly integrated into Hadoop. MySQL is a popular relational database that is free and is often something you'll need to integrate with for both importing and exporting data. We talked about MongoDB, which is similar to HBase in design, but is more general purpose in nature and can actually be used as an entire engine of its own. And Cassandra, which is another NoSQL non-relational database, but its architecture is made to favor availability above all else. So if you need a lot of uptime but don't really care so much about consistency, Cassandra is a very good option for you there. We talked about Scoop. Scoop is a way to import and export data from your MySQL or any relational database that you want easily into your cluster at scale, using MapReduce under the hood to distribute that importing and exporting. And moving over here, we talked about Zookeeper, which is just a piece of infrastructure that various systems can use to keep track of things like who is the current master server in a very reliable manner, and Oozie, which just maintains workflows and lets you schedule jobs across your cluster that run repeatedly over time. Over here, we talked about some different query engines that can sit on top of your cluster, and we have things like Drill and Phoenix and Presto that can allow you to write SQL queries that might span multiple storage or database technologies that might be associated with your cluster. We talked about Hue, which is basically Cloudera's answer to Ambari, which, as well as allowing you to maintain and manage your services, it provides a web user interface for interacting with many of them. And Apache Zeppelin, which offers a IPython notebook-style interface for interacting with your data. So if you're coming from a data science background and you're familiar with IPython, you'll be right at home with Apache Zeppelin. Moving back in, we also talked about streaming technologies, Apache Storm being one of them that's more tightly integrated into Hadoop. And we talked about some alternatives, such as Spark Streaming, which is also very popular, and Flink, which is an up-and-coming one that's pretty hot. And we talked about Flume and Kafka, which are both technologies for streaming data into your cluster at scale. You can move data from one cluster to another reliably and at very high transaction rates using Flume and Kafka. And sitting on top of it all is Apache Ambari, which in the Hortonworks distribution allows you to install and manage your services, as well as provides a web interface for interacting with some of it, like working with your HDFS file system or issuing Hive queries and things like that. And that, in a nutshell, is what we've covered in this course. And wow, it's a lot of stuff. So it's important to know what's in your tool chest when you're trying to solve a problem. What are the bits that I have available to me? And if you have a good feeling of what all these components are capable of, then we can start to talk about how to put them together to solve specific real-world problems. So let's do that next.